Alright, so in this problem, I have 2 to the power of m minus 2 to the power of n is equal to 2016. So at first glance of this problem, I know that 2 to the power of m is greater than 2 to the power of n. Because if 2 to the power of m was less than 2 to the power of n, then this would not be a positive number, this would be a negative number. So if 2 to the power of m is greater than 2 to the power of n, then this also means that m is greater than n, because they're both the same base. So now that I know that m is greater than n, this must mean that m is equal to n plus some number k. So k is just a constant, some number. So now I'm going to replace m with n plus k. So now I have 2 to the power of n plus k minus 2 to the power of n is equal to 2016. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of n plus k, that's going to equal 2 to the power of n times 2 to the power of k. Now this minus 2 to the power of n is equal to 2016. Now I'm going to factor out 2 to the power of n. So now I have 2 to the power of n times 2 to the power of k minus 1 is equal to 2016. So 2016, this is equal to 32 times 63. So as you can see here, 2 to the power of n, this is going to be an even number, right? Even, because 2 to the power of any number is even. Now 2 to the power of k, that's even, but an even number minus 1 is going to be odd. So 2 to the power of n is even, and 2 to the power of k minus 1 is odd. So now 32 here, this is even, and 63, this is odd. And notice how both of these are in the form a number times another number is equal to another number times another number. These two numbers are even, these two numbers are odd, meaning 2 to the power of n is equal to 32, and 2 to the power of k minus 1 is equal to 63. So these are my two equations. First off, 2 to the power of n equals 32. We know that n is equal to 5 because 2 to the power of 5 is equal to 32. And 2 to the power of k minus 1 equals 63. I'm going to first start by adding 1 on both sides. So now I have 2 to the power of k is equal to 64. So 2 to the power of what number equals 64? 6, meaning k equals 6. So I have my value for n and k, so all we have left to do is find the value of m. And remember, m is equal to n plus k. So n is 5, k is 6, meaning m is 11. Alright, so in this problem, I have 100 to the power of x is equal to 200. So to solve this, I'm going to first take the log on both sides. So now I have log of 100 to the power of x is equal to log 200. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is equal to b times log a. So in this case, I have log 100 to the power of x, and I can move x to the front. So now I have x times log 100 is equal to log 200. Now, I'm going to divide both sides by log 100. So then these two cancel out. And now I have x is equal to log 200 over log 100. Now log 200, this is the same thing as log of 100 times 2. And I have this over log 100. So now if I have something in the form log of a times b, this is equal to log a plus log b. So log 100 times 2, that's going to equal log 100 plus log 2. And now I have this over log 100. So now I have log 100 over log 100 plus log 2 over log 100. Now log 100 is simply equal to 2. So I have 2 over 2 plus log 2 over log 100. which is equal to 1 plus log 2 over 2. Alright, so in this problem, I have 3 to the power of x is equal to 7 to the power of x plus 2. So to solve this, first off, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 7 to the power of x plus 2, I can rewrite as 7 to the power of x times 7 to the power of 2. Now, I'm going to go ahead and divide both sides by 7 to the power of x. So then these two cancel out, and now I'm left with 3 to the power of x over 7 to the power of x is equal to 7 squared. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to, a to the power of m or b to the power of m, this is equal to a over b to the power of m. So 3 to the power of x over 7 to the power of x, that's going to equal 3 over 7 to the power of x, which is equal to 7 squared. And now I'm going to take the log on both sides, so I have log 3 over 7 to the power of x is equal to log 7 squared. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so this is going to equal b times log a. So log of 3 over 7 to the power of x, I can move x to the front, and log 7 squared, I can move 2 to the front. So now I have x times log 3 over 7 is equal to 2 times log 7. And now if I divide both sides by log of 3 over 7, these two cancel out, and I have x is equal to 2 log 7 over log 3 over 7. Now, if I have something in the form log a over b, this is equal to log a minus log b. So log 3 over 7, that's going to equal log 3 minus log 7. So this is my answer. Alright, so in this problem, I have 100 to the power of x